Okay, all we want to do is get through these three examples. Distance an object has fallen from a still position in meters after t seconds is modeled by that equation. S of t, or the distance, is equal to 4.9 times the amount of time squared. So for example, I am holding an object as a stick figure here, okay? And I am dropping this object, okay? Okay, we're at a ledge. And the fact is, at this time would say be 0 seconds, and then say 1 second, and then say 2 seconds, and then say 3 seconds. The question is, find the average velocity for the time period beginning with time equals 3 seconds and lasting 1 second. So if I'm looking at the time period starting at 3 seconds and lasting 1 second, what would be the other time that I would be checking? I'm starting at 3 and it lasts for 1 second. 4. So that's my interval that I'm going to be checking. What if it's lasting 0.5 seconds? And 0.1? Very good. And 3, 3.01. So what's happening in the interval as I move along here? It's getting smaller, it's getting closer to 3. So right now we're looking at the average velocity. Average velocity is where you take slope. 2 points. Really, the secant line. You're finding the slope of the secant line. As we shorten the interval, we'll be looking to find the instantaneous velocity, which is the slope of the tangent line. In order to find slope, I just need 2 points. I'll find my point P and my point Q. Point P has an x value of what? 3. How do I find the y value? Plug it in. So I take 4.9 times 3 squared, and I get 44.1. What is the x value for Q? 4. And how do you find the y value? Plug it in. It's the interval. These are my different x values. So you type in 4, 4.9 times 4 squared. We get 78.4. So if you instead would like to write a slope function, as you guys were talking about, and say, let's say you wanted to do 4.9 x squared minus 44.1 divided by x minus 3, you could do that. That would be fine. Okay? So instead of Q being 4 and 78.4, if you chose Q to be x and 4.9x squared, that's fine. Okay? But we want to find this slope. And in order to find the slope, you subtract the y values, 78.4 minus 44.1 divided by 4 minus 3, and I get 34.3. 34.3 what? What is our measurement in? Meters per second. Okay, we'll pick up with there when we get back. Go get some brain food. Okay, folks, hopefully you had some good brain food. Everybody clear how we came up with 34.3? Okay, can you please finish off then 2, 3, and 4? So your interval then goes from 3 to 3.5, 3 to 3.1, 3 to 3.01. If you would like to, do it by hand every time, that's fine. If you'd like to write yourself a slope function and do it, it's entirely up to you. So I'll let you go ahead and do that. Catherine, you have a question? You sure? Okay. Do you think Maddie is smarter than me? Is that the deal? 2 steps against. I Brago anytime. You should be coming with 31.85 for the second one. Third one should be 29.89. Third one should be 29.449 meters per second. Questions out there? You guys are kind of. What's the question? Which one? Okay. So if you did it by hand, you could simply grab 2 points. Your first point was 3:44.1. That doesn't change. Your second point would be 3.5. And as you plug that in, 4.9 times 3.5 squared, you get 60.025. Subtract those values, minus the 44.1, divided by 0.5, and you get 31.85. Because that's your x of 2 minus x of 1 will give you 0.5. Just simply the difference in your x values. So whether you did it by hand or you wrote a slope function in your calculator and punched in your table values, either way you can come up with those values. So let me try to make sense of this. This is the big conceptual piece. I could teach you guys how to do a lot of the algebra within calculus, but whether or not you understand conceptually what's going on, that's a little bit different. So here's my attempt at this. I'm driving home. It takes me 30 minutes to get home. I'm traveling a total of 30 miles. Can somebody tell me what is my average speed on the way home? Yep, 60 miles per hour. Okay? Are we okay with that? So, does that mean I'm going 60 miles per hour every single moment on the way home? That's my average. When I'm driving by Mrs. Wayne's farm, I'm probably going more like 72 miles an hour. Okay? I usually go a couple miles over the speed limit because I'm a bad person. Now, that's the difference. Notice what we're looking at in this problem. It says average velocity. That would be like my average speed on the way home is 60 miles per hour. That would be the slope of the secant line, 2 points. But we would like to know the instantaneous velocity, or the slope of the tangent line. So if we are looking at the instantaneous velocity when time is equal to 3, somebody got an estimation? Well, look at what's happening. 3 to 4, 3 to 3.5, 3 to 3.1, 3 to 3.01. We're getting closer to, we're looking at basically just 1 point, right? So where do you think it's headed towards? We have 34.3, 31.85, 29.89, 29.449. You think it's headed about 29, okay? 29 meters per second. Somebody have a different guess? Well, I mean, there's lots. We don't know for sure until we really look at the table a little bit more. Notice if I go 3.00001 and then 3.00001, you can see that it looks like it's actually headed to 29.4. But you wouldn't know that unless you carried it out a little bit further, right? So either one of these is an acceptable answer, okay? We're based off the data that we have, both of these seem quite reasonable. You agreed? You okay with that? We looked at the data. It looks like that's about where it's heading. Not until we actually go past the 0.01 to even a smaller time interval do we actually find the exact answer. Okay, so let's look at some table values. These next two problems will model what you need to do in your assignment today. So the number of bacteria in a dish is modeled by the given data after t minutes. So at 1 minute, there's 5 bacteria. At 4 minutes, there's 8. At 8, there's 14. At 13, there's 32. At 20, there's 115. Okay, what do you notice is happening to the bacteria? That looks like it's growing exponentially, doesn't it? Yeah, very, very good answer, and that's exactly what's happening. So it says find the average rate of growth. Average rate of growth requires how many points? Requires 2 points. So we will look for a point P and a point Q, okay? Beginning at time equals 1. So what's my first coordinate? At time 1, how many bacteria are there? 5, okay? And at time Q, point Q, so it's going to last for 19 minutes. If it's lasted 19 minutes, what time is it? It's time 20. And how many are there? 115. So I will take y sub 2 minus y sub 1, which is 110, over 19. I'm going to do x sub 2 minus x sub 1. So my change in y over my change in x. And if I divide that, 110 divided by 19, you can see that I have 5.8 or 5.79. And what's my label? Bacteria per, yep, it's a rate. So it will include, growth, or whatever's changing the bacteria. And then in this case, over time, which is measured in minutes. For number 2, does point P change? No, point P is 1.5. Does point Q change? Yeah, to what? 1332. Go ahead and please finish off the chart. Okay. What did you get for 3? Or how about 2? Let's start with 2. What did you get for 2? Okay, how about for 3? And the last one. So what do you notice? Yeah, it's going down. As you have a short time interval at the beginning, the bacteria are not growing as quick of a rate, are they? Why? There's fewer of them. Okay, the more bacteria you have, the more bacteria they're going to produce, right? That's the way it goes. Okay, now look at the next question. And this is the big point. This is what you're going to have to be able to do on your assignment today. It says, use a graph of the data in order to estimate the instantaneous rate of growth at time equals 8. Okay, now at time equals 8, we know that there's 14 bacteria. But is it growing at a rate of 5.79? Is it growing at a rate of 1? Is it growing at a rate of 2.25? What would you estimate the rate of growth to be? And so we're going to look at a graph, okay? And this is the part that you have to understand. You don't actually have to make a graph into your assignment. You should be able to just look at this and figure it out. And I'll show you how that will work. But don't draw this graph, just kind of watch what I'm doing. I made a graph with time and bacteria. Now, at time 1, there's how many bacteria? 5. So I'm going to put a point there. What's my next point? What do I got? 4 and 8. Okay. My next one. 8, 14. Okay. My next one. And then 21. It's way up here, right? So as you guys stated earlier, you would expect to see an exponential curve. Does that look like an exponential curve? The question is, we need to be able to estimate the instantaneous rate of change at time equals 8. Or in other words, I want to know the slope of the tangent line right at time equals 8. Okay? I don't have a function. I simply have these pieces of data. Can somebody think of how to choose a couple points up there that will estimate the slope of the tangent line? Can somebody think of a secant line that would estimate the slope of a tangent line? If I connected the first one and the last one, do you think that that would be a good approximation for the slope of the tangent line? How about if I picked the fourth one and the fifth one? Do you think that would be? Which two do you think I should pick? So you would say the third and the fourth. I think that the third and fourth would be a pretty good choice. I think that the best choice would be, I think that the second and the fourth, it bridges right over that middle of 8. Do you guys see that? Would you agree that if I pick the one before it and the one after, hopefully that will give a really good representation of what's in between it? You agree? So I didn't even need to necessarily look at the graph. What I could do is, if I want to estimate the instantaneous rate of change right here, I can use these two sets of data points. So I will do that. Y sub 2 would be 32 minus y sub 1, 8 over 24 divided by 9, 2.666. That's actually a question right from the AP exam, you guys. You're going to see a question like that in the AP exam, I promise you. Is it difficult mathematics to do? Is it difficult to maybe think, though, about what they're asking? Does that make sense? If we don't have a function, you want to estimate it right here, you got to choose a couple of data points. Don't choose these two. Don't choose those two. Pick the one before and the one after. Better? Okay, let's go to the last one then. It says use the graph below to draw a line tangent to the function at the given point. Then determine the equation for the line tangent. So determine the equation for the line tangent. What two things do I need to determine the equation for line tangent? Slope and point on the line. What is the x value for the point on the line? How do I find the y value? So this is 0.75 right here. Okay, so I will draw a tangent line at that spot. What would you say is the y value there? Anybody want to take a guess? Did you say 0.9? Is everybody okay with that? This is totally an estimation, you guys. There could be a variety of answers here, and that's all right. So I'm going to choose 0.9 as my y value. Looks like that's about where I would be. Okay, so I'm going to draw that tangent line. You're okay with that? Okay, so I got a nice tangent line. So how would I estimate the slope? I have a point P, which we will call 0.75, and 0.9. In order to estimate the slope, I need a second point. Can somebody suggest to me what might be a second point on that line? Got lots of choices here. 0.25 and 0.6. Is that what it shows, Maddie? 0.25 and 0.6 is a reasonable choice. I would also consider choosing, say, 0 and 0.5. I think any of those choices are fine. 0 and 0.5 or 0.25 and 0.6. I think any of those choices are acceptable. Everybody okay with that? Can I now find the slope? Y sub 2 minus y sub 1 be 0.5, or I'll go the other way. 0.9 minus 0.5 is 0.4 divided by 0.75. And I get 0.53 repeating. Now I'm going to write my equation for my line. Does anybody see why I chose to use 0.5? It could make it really easy for me to write the equation for the line, isn't it? Y equals mx plus b. 0.53 repeating times x plus the y-intercept, 0.5. Let me recap to show you what we've done. We've looked at a graph and written the equation for a line tangent by estimating. We've looked at data points and written equations for lines tangent estimating as well. And finally, the last thing that we did is, last week on Friday, we did this type of situation where we're actually given a function. We found the exact equation for line tangent. All three pieces you're going to be expected to do for the AP exam. I want to make sure you saw all three. So your assignment, if you take out the worksheet I gave you on Friday, is simply the back page. Notice you just have 4 problems. You have 2 with tables, which goes exactly with what I showed you to do for the table part. And then you have 2 with graphs, which is exactly like what we just did. So there's not that much extra, is there? Okay. All right. Excellent. Short week. Only school through Friday, so or through Thursday. So let's make sure we stay on top of our math. And good work.